Dear ladies and gentlemen, Damien O'Brien, the first and responsible author, unfortunately could not attend the meeting. So our global technical director asked me. So I'm not living in Belgium, I'm living in Austria. Damien in Australia, so I thought that sounds similar, so let's do the study. Unfortunately, after accepting this, I had to find out that the beef cattle industry is really different between Austria and Australia. And to give you some facts for the background of our study, a few words about the beef cattle industry in this big country and continent. There are around 11.5 million beef cows and heifers more than 1 year old in Australia. So it's quite a big number, quite a huge industry. The main breeds are British breeds like Angus or Hereford or the Bos Indicus breeds. And these cattle are mainly raised in cow-calves operations. A herd size differs a little bit in the country. In the south we have around 400 cows. In the northern part of Australia it's 1,500 cows. So really big herds. And the feedlots, they are buying the calves. They are buying the calves at any age between 6 months and 12 months. And that is now the challenge for the owner of the cow-calf operation. Why is this challenge? The main disease problem for the feedlots is bovine respiratory disease, as probably everywhere in the world. The main pathogen in Australia is IBR virus and Mannheimia hemolytica. So what the feedlots owner wants, that if they buy the calves, that they are vaccinated at least one time against these both pathogens. Now there is a wonderful combined vaccine available in Australia. Unfortunately, it has a very strict time interval between first injection and the booster. It's 3 weeks. So now imagine that the feedlots are asking for cattle at different ages, at different time points. At any time, the owner of the cow-calf operation has to gather all the animals to find the special calves, vaccinate them 3 weeks in advance to sell them at the point the feedlot wants the cattle. So this is really a challenge, and what the farmers and the veterinarian ask for is, of course, a more flexibility in this time interval to facilitate their work of vaccination, the animals. That's why we set up this study. We wanted to evaluate the serological response in cattle to a bivalent inactivated vaccine, and we vary it in the primary to booster intervals. The vaccine we used for this study is the Cooper's Bovilis Mannheimia hemolytica plus IBR vaccine. It's developed in Australia, manufactured in Australia, so it's really fit wonderful in the beef cattle industry in this country. Our hypothesis was that there are no changes in the serological response 14 days after booster if we have the different time intervals. We used 9 old month Angus calves, and we randomly assigned them to 8 different groups. The first group was a control group, not to show the efficacy of the vaccine, we know that it works, but to show that no field infection occurred during our study, because any field infection would also lead to an production of antibody, and then we would not really conclude it is only the effect of the vaccine or any other effect. And then we had 7 vaccines group with different time intervals, starting from 10 days, and the longest interval was 9 months. And the critical comparison, especially also for the legal authorities, was what is the serological response to the vaccine given after the various time points 14 days after the booster vaccination. And we compared this to the label group, and remember the label group was the time interval of 3 weeks. To measure the antibodies, we had to take blood samples. Here you see the 3 different time points when we took the blood samples. We used a commercial kit to measure the IBR antibodies. It's from IDEX. And we use our in-house ELISA in Boxmeer in the Netherlands to measure the Mannheimia hemolytica antibodies. And we looked at the response to the priming dose, so we wanted, of course, also know how long last the antibodies produced after the first vaccination in the calves, and as I said before, what is the response on the booster vaccination. For the antibody we measured showed an uneven distribution. We used non-parametric methods to do the statistical analysis. Here they are listed: Kruskal-Wallis for the comparison with the control group, and Wilcoxon-Rank sum test for the control of the vaccine groups compared to the label group. And we did another analysis. Animal can have a certain amount of antibody, but it could be seropositive or seronegative, especially for IBR. You see you have a certain threshold what the animal has to meet to be seropositive. And so we also evaluated the proportion of seropositive animals in the control group and, of course, in the different vaccine groups. The threshold for Mannheimia antibodies was 5.6 on a log base 2 scale. And for this analysis, we used the chi-squared test. That's material and methods that show the results. All the graphs I will show you, I have the same structure. On the x-axis, you see the different groups, starting at the far left with the control group, and then you see the different time points for the time intervals we used for the booster vaccination. Remember, 3 weeks is the label group. And on the y-axis, you have the amount of antibodies. In case for IBR, it's the percentage of blocking. Before vaccination, all animals were seronegative. You remember the threshold is 55% of blocking, and you see all the values are clearly below this level. After the first vaccination, when we looked before the booster at the different time points, you see a quite different picture. The control groups remained seronegative, and all but 1 animals in all vaccines groups were seropositive. So this difference was statistically significant, and there were no differences from the label group to all other vaccine groups. So a quite good result, and especially a good result that we could find seropositive calves even after 6 months or 9 months after the first vaccination. What happens after the booster vaccination? More or less the same picture. The control calves are still seronegative, so there was no field infection during our study with IBR virus. A much more homogeneous picture in all the vaccines group instead of the final group where we vaccinated the calves 9 months after the first vaccination. But in total, a clear picture that we can say, okay, we can vaccinate, we can use the vaccine at different time points and we'll have the same serological response after the booster vaccination. That's for IBR. What was the picture? What were the results for Mannheimia hemolytica? All animals were, even before the first vaccination, already serological positive. So there might have been some field infection before we started our study. Nevertheless, you see a quite variation of antibody titers within each of our groups. And at one point, at the control group, you see here the black spot, that is the mean, it's around 12 on our log2 scale. Keep this in mind. Now I show you the results after the booster. And what you could see is that the titer of antibodies increased in all of the vaccine groups, and this was more homologous levels, so not this wide variation we had before. There was a decrease in the mean of the antibody titer in the control group. So over the time, there is a decrease, as we all know, that is physiological. Nevertheless, it also shows probably no field infection of Mannheimia also during our study. That's also fine. And the different levels here showed no difference, no statistical difference compared to the label group. So, in conclusion, to sum up our study, we could accept our hypothesis because we showed no differences neither in the IBR serological response nor in the Mannheimer Hemolytica serological response when we used this bivalent vaccine at different time points starting from 10 days up to 9 months. We gave this data to the legal authorities in Australia. They looked at the data, evaluated them, and also approved them. As legal authorities always do, they put some safety margin in it. Nevertheless, they approved now that we could change the label of this vaccine. So now it's able to use this vaccine with a more flexible time interval between first and booster vaccination from 13 days up to 6 months. That's more convenient for the farmer because now he can vaccinate more cattle at the same time because he has more flexibilities in selling his calves at different times in the future. And here is what Australian Angus bull is saying to our study. It seems he's happy. If you agree, I'm also happy. If you don't agree, I'm happy to answer your questions.
Thank you very much for